What's up everyone, Patrick here, welcome back. And in this next video, we have to find the solution to these inequalities here. So a couple of double compound inequalities. So starting with number 1, we got 3x minus 5 is greater than or equal to negative 14, but it's less than or equal to 2. So how would we find the solution to that? Personally, what I like to do is I actually notice there's two inequalities here. I actually like to work with these separately. Sometimes you'll see this taught in a way where they combine them. Like they'll add 5 here to get rid of this negative 5, so they add 5 to here, add 5 to here, then divide everything by 3. I personally don't like doing it like that. I like to split it up. This takes a little bit longer, but I feel like the chances of making a mistake are lower here because it's super easy to just isolate for that variable. You just bring the negative 5 over, so negative 14 plus 5 would give us negative 9. Like that, divide both sides by 3. So from this side here, all the x values have to be greater than or equal to negative 3. Then when you do the same thing here, isolate for the x, 3x is less than or equal to, bring this over, 2 plus 5 would be 7, divide both sides by 3. From this side, all the x values have to be less than or equal to 7 over 3. So from here, all the x values have to be greater than or equal to negative 3, but all the x values have to be less than or equal to 7 over 3. So if we combine these into a solution, basically x has to be between negative 3 and 7 over 3. Right? That would be the answer to number 1. If you wanted to represent that on a number line, say we got 0 here, negative 3, 7 over 3, that's like over here. And because it's inclusive of the ends, solid dots, and it basically would be all these x values right there. Right? If this was just greater than, less than, these would be open dots here, but it's inclusive of those ends, so these are closed dots. All right, so this here is the solution. This is graphed on a number line. You can also put this in interval notation, so you could say all the x values between negative 3 and 7 over 3, inclusive of both, so we put square brackets here. Right, different ways to represent the solution. Moving on to number 2, same sort of thing. We got this. So what I'm going to do is split up that inequality into 2 separate ones, work with them separately. And then this one would be 1 over 5x plus 2 is less than 4. So over here, bring the 2 over, so negative 5, like that. And then, isolating for the x, we divide both sides by 1 over 5. Another thing we could do is multiply both sides by 5. Dividing by 1 over 5, multiplying by 5, those are the exact same thing. So we could have just multiplied this by 5, multiplied this by 5, whichever way you do it, x is greater than or equal to negative 25 from this side over here. Right? Another thing, if you'd rather not work with fractions, is you could take this. I've done this in previous examples. Then notice this is over 1, this is over 1. You can multiply everything by the lowest common denominator. Just make sure when you're multiplying everything, it's by a positive value, so you don't have to worry about flipping this. So multiply this by 5, multiply this by 5, this by 5. So you'd end up with negative 15. This would just be x. This would be 10. Bring this over. X is greater than or equal to negative 25. Right? Same solution that you get. So that's the solution to this. Now to the second one, what we would do is bring the 2 over, less than or equal to 2. Right? 4 minus 2 is 2. Multiplied by 5, multiplied by 5. X is less than 10. Right? So now all the x values have to be less than 10, but greater than or equal to negative 25. So if we combine these, basically x is greater than or equal to negative 25, but less than 10. Right? And be careful with the inequality signs. This one was a greater than, x is greater than or equal to. This one was an x is less than. Right? So just be careful with that. If you represent this on a number line, we got 0. Let's say this is negative 25. Let's say this is positive 10. It's not inclusive of the 10. It's just x is less than 10, but it is inclusive of the negative 25. All the x values greater than or equal to negative 25. So filling this in, it would look like that. If you want to put the solution in interval notation, we would say negative 25, positive 10, but that would be a circle bracket right there because it's not inclusive of the 10. Here it's a square bracket because it is inclusive of the negative 25. Right, so different ways to represent this solution. These here, these two are just the separate solutions, but you always have to make sure you combine them. Right? When you combine them, these are the solutions you would get. Now with number 3, notice it's the exact same thing, but the only thing that's changing is it's a negative 1 over 5, which is actually going to change the solution quite a bit. So this would end up being negative 1 over 5. This would end up being negative 1 over 5. So personally, as you've seen in previous videos, when I isolate for the x, I like to do it in a way where when I'm going to divide by that coefficient in front of the x, I like it to be positive. So I'm going to bring this over, and then I'm going to bring the negative 3 over. So we'd end up with positive 1 over 5x on the left side. 2 plus 3 is 5. Multiply by 5, multiply by 5. So x is less than or equal to 25. That's what we get here. Before it was x is greater than or equal to negative 25. Here it's x is less than 25. So it changes the solution quite a bit. Over here, I'm going to bring the negative 1 over 5x over. I'm going to bring the 4 over. So 2 minus 4 is negative 2. Positive 1 over 5x multiplied by 5, multiplied by 5. So in this case, x is greater than negative 10. So in this case, it's kind of like flipped over. All the x values are greater than negative 10, but less than or equal to 25. So when we combine this, we would say x is greater than negative 10, but less than or equal to 25. That would be the final solution. On a number line, 25, negative 10, not inclusive of that, inclusive of that. So it would be all the values right there. And then in interval notation, we would say from negative 10 to positive 25, inclusive of the positive 25. So that's a square bracket. It's not inclusive of the negative 10, so that is a circle bracket. You could test this, so you could pick any number here and plug it in. So an easy number to pick is 0, plug it in for x. This would go away, so you'd end up with negative 3 is, or we get 2 is greater than or equal to negative 3, but less than 4. Is that a valid statement? It is, right? 2 is greater than or equal to negative 3 and less than 4. If you picked something outside here, let's say we picked like negative 20. If I plug in negative 20 over here, negative 1 over 5 times negative 20 would give us positive 4. This would be plus 2, so we'd end up with a 6 over here. Notice that 6 is greater than or equal to negative 3, but it's not less than 4, so that wouldn't be a valid statement. And so that's how you know negative 20 would not be part of the solution. So you could always test your solutions as well by taking that x value, plugging it in, and then seeing if that resulting statement makes sense or not.